Great. So my name is Javed. I hope you got some time to look at my introduction. If not, let me take a moment to give you a short, brief introduction about myself. So I play multiple roles. Primarily, I consider myself as a researcher slash a scientist, but along with that, I call myself an educationist. I like to teach people, and I like to teach things, complex things, in a very simple manner. Along with that, I volunteer myself with a lot of IEEE activities as a speaker, a volunteer, and a leader. I also am an entrepreneur, was an entrepreneur for some time till I joined Intel for recently. I love nature. I like spending time in nature and learning from various aspects of nature. And I use the camera to record those memories. I have been an online teacher for quite some time. So I have taught various advanced and basic courses in analog circuit design, right from ADC, high-speed serial links like SerDes, LDO design, capacitance to digital conversion or a lab on a chip application, CMOS analog circuit design and IC design with specifics to amplifiers and MOSFET. So I have been involved with teaching for quite some time, and you can find many of these of my courses online. And if you look at the base in which you have to construct the analog design course, you have a basics course, then you have amplifiers, solved example of amplifiers. After that, you can go into learning operational amplifiers. Once those basics are done, you can jump to the more advanced topics of BGR, LDO, PLL, ADC, and DAC. On top of this, you have the high-speed SerDes block, which you have SerDes channel response, serializer and deserializer, TX driver, CTLE, and really high-speed CTLE and others. So quick brief about the various projects that I have done in the last decade and a half. I'm working on, I did my work on a lab on a chip where we had integrated instrumentation circuits. Okay. May I request the participants to mute if you're not speaking? So all the participants who are not speaking, may I request you to mute? Thank you. So the first project was on integrated instrumentation circuits for biomedical diagnosis, which was a lab on a chip circuit. From there on, I moved to work on electrothermal integrated circuit and electrical characterization of circuits. Next project was high-speed SerDes, and in high-speed SerDes we did a course understanding from 1.25 to 40 Gbps, right? Then to make these circuits work, we worked on high-frequency phase lock loops to understand what are the phase lock that is needed. Finally, a lot of my pet projects where I did innovative electronic solutions for IoT in agriculture. So these are the various pet projects which I have been doing in the last decade and a half. And with this, I would like to give you a quick overview of what this course might be for you. So the way we will take this is, first, we will understand what is a transistor, right? We will start building a transistor and take things forward. So understand what is a 3-terminal CMOS device first. Next, we will learn about biasing this circuit. What does it mean by biasing? Finding out the VGS of this device. What is the current that it will draw? What is the geometry? of this device, which is defined as W by L. In this, how much capacitance is going to be present? That would be CGS. How much the capacitance is present on the drain side, CGD. Right? Once you know, this is called the biasing. After biasing, we will learn how to use this as an amplifier circuit. Right? It is called a single stage amplifiers. Where you have common source, common drain, and common gate configuration. Once you understand single stage, we will try and do this will be called as single-ended amplifiers. After doing single-ended amplifiers, we will move towards differential amplifiers. Right? We will understand what is a differential amplifiers and what are the various applications of a differential amplifier. So this is a differential amplifier. Now this disemplened amplifier has a ton of applications. So what can be used? It can be as gain stage. It can be used as a delay cell. It can be used as a comparator. Third, fourth, it can be used as an amplifier, or what we commonly call as operational transconductance amplifier, or OTA. So we will know these four items in this. Once we know these four, we will look at how you can use this amplifier in creating what is called as an operational amplifier. What is an op-amp? So in an operational amplifier, you will understand how do you use this, what is the gain,
sir, I have joined, sir.
what is the phase, then how do you do compensation. After doing this, you need to understand how much noise each one of these are going to contribute. So you will understand about thermal noise, environment noise of this device. After understanding this noise, now you will come into the picture. Okay, now we have got the basics. Now we will go into the next set of circuits, which are called current mirrors. After you understand what is current mirror, you will know what are all the basics. So you will understand how you can add a current, how you can subtract current, how you can multiply current. Division is currently executed using subtraction only. With this, you will know how to do gain boosting. With gain boosting, you will be able to understand what are the impedances that you need to handle. Right? Impedance will be input impedance, output impedance. So this will all take care of current mirrors. Once you have completed current mirrors and operational amplifiers, you are now equipped for bigger designs. So what are the bigger designs that I will introduce you? Bigger designs would first be understanding what is feedback. In feedback, very important is negative feedback. This is the base for almost all circuits that are present. So once you understand feedback and negative feedback, you will now start implementing designs with an op-amp based circuit, right? So the first circuit that you will understand is called a band gap reference. We will look at how do you construct band gap reference, and with that you will also be able to understand what is called PTAT designs, proportional to absolute temperature based designs you will look. So you will understand how to do first a voltage and a current reference. Once you do that, you will build second what is going to be called as a LDO. You can build an LDO. We will touch base on how you can do LDO. So what is an LDO? LDO is a power management circuit which uses an amplifier to pass standard reference currents when it is controlled in a feedback which is driven by a BGR with a reference voltage. So you here will have the LDO in, next will be your LDO out. LDO is designed for a fixed current or voltage. We will take you through this experience. After that, after LDO, we will introduce you to what is an ADC. Right? Now, what is ADC? ADC is an analog to digital converter. We will also introduce you to the other way around, which is the digital to analog converter. Right? In this, there are many branches. We will look at some of the basic ones and explain. First one we will teach you is the R to R ladder, the most basic ADC, and similarly, this would be the similar R to R ladder in the PSC. Then you have the capacitive DAC, very common for systems. Next, we will teach you in analog ADCs, we will teach you SAR ADC. SAR ADC is like your binary logic, right? So you will use SAR ADC. After that, we will introduce, only we will not go into detail, what is called as flash ADC. And what is a sigma delta? So these two are only going to be introductions. We will not go into detail. But we can go into detail in one condition. I will come to that a little later. After capacitive DAC, you can do current DAC, which is called IDAC. So these are the three which we will introduce to you so that you can do. If time permits, we will introduce a simple ring oscillator for frequency generation circuits. Ring oscillator for frequency generation. And this is a family, comes under the family of voltage controlled oscillators or VCO. So voltage controlled oscillator means you will have an oscillator and its operation, frequency, tuning range will be controlled using an external voltage. Now with this in ring oscillator, you will come across terms like phase noise. You will come across frequency range. And you will also come across what is tuning range. Okay, and its small signal analysis. So this is what we will look at. Now, this is all the theory part, right? Now, with the theory, that is available, we will do some amount of practicals. Now, practicals, I will take the help of the PhD student who has just joined, PhD scholar. They will help us. I will ask Professor Manoj to give her details later, and we will have Dr. Manoj also assisting me in teaching this course here. So in this practicals, you will be expected to learn the tool. So the commonly used industry tool is going to be Cadence. So we have something called the PDK. So we can either use a general PDK or we will use a foundry based equivalent PDK. With this PDK, we will do all our simulations plus layouts if possible, if the time permits, right? So this would be the expectation. Practicals, I will discuss in another class to understand what are the nature of experiments that we will do. Because fundamentally, every class will have one or two experiments that we will go through, and you will do it in your lab time. Now there is in this particular course, I prefer learning by doing. So what we will be doing? We will be doing a project. Now the complete class will be divided into any number of groups, and those number of groups will get to choose projects from one of these which we will list on. First one, an LDO design, right? Second one, ring oscillator design. Third one, two types of op-amp, which could be folded cascode, another one is high input, high output, swing op-amp. Last one would be differential pair design. Differential pair design for 5 gigahertz and above frequencies. So these are the 4 projects that are going to get offered. So the rules of the project will be end of the course, you have to finish one of these 4 projects. You will get to decide the project by September 15. September 15, 2022. Please send me an email on what is the choice that you're doing. Now, since we have about 25 or 20 people, we will keep them in groups of 2 per team. So with 22 people, we were 25 people or 20 projects. We will get about 10 projects. These are all industry relevant projects. Right? Now there is a catch to it here. Now, if these projects are good, we will submit these to either a journal for publication, and you will do it for a conference. So out of these two, aim is minimum 2 papers have to come out. So we will maintain the quality at that high standard. The project deliverable, right? Now, how do you deliver the project? Project deliverable will be one. We will not ask a project report. We will ask a 6-page, 2-column IEEE paper format. Right? So what does this mean? This means you will be writing an IEEE paper based project report. What does that mean? You will have the following sections. 1, introduction. This will contain the overview of the problem statement. Right? Second, we will discuss what is the proposed solution for the above problem statement. Third, you will discuss what is the circuit design. Fourth, you will show the simulation results. After the simulation results, you will do a comparison and summary. For example, summary. This project will take 25% of total marks or your grade. Okay. So here, very easy way of getting 25%. Next one would be class presentation. What does class presentation involve? Your design, your class project design, you will present to your class, right? This will be in person. Why is this in person? I will probably travel to campus and we will sit and listen to all your 10 presentations in one day, right? So each of your projects. So this will take 10% of your marks. Okay. So in this course, I will try and follow it possibly that the final exam in written format is equal to your IEEE paper plus presentation. So this 35% will come from there. Right? Then we will have assignments. every alternative week you will get an assignment of either solving a problem or performing a simulation and showing the result. The result will be viewed by the PhD scholar who is going to assist in this class and myself. Henceforth, we will call that PhD scholar as our teaching assistant, who will be officially the teaching assistant of this course. This will give you 20% of your marks. So this, without doing any exam, you are guaranteed of 55% score you can target. The rest 45% are with test. You will have one test, test 1 and test 2, which would be your course where you would be 25 marks each, right? And this 25 marks will now be weighted, averaged equally, right? Weighted averaged equally to finally end up with 45 marks here. So in total, 35, 45, 20 would give you your 100%. So this is my proposed format. Now let me listen to the students to see, do they agree or is this okay with them? So if you have any concerns, please speak up.
Yeah, Dr. Jafar, actually, I just want to say something. Yeah, test 1 and test 2 means actually mid-sem exam and final exam actually.
Mid-sem exam and final exam.
Yeah. So final exam carries 40% weightage, and rest of the 60% weightage you can divide with this one, this assignment, test 1, test 2, and final exam. That one, this one, the IT paper presentation, everything. So you can do it.
Okay. Could you kindly confirm?
So I'll discuss with you later. Leave these things to the students actually.
Okay.
So
no, we can make it simple. So if the final exam is going to be 40%.
The weightage will be the 40%, and rest of the 60% it will be internal this one, which including this your assignment, mid-sem, and this presentation, ITP format, or these things, everything.
Okay, that is wonderful. Okay. In that case, let me give you the breakup right away. So final is 40%.
What is 40%? Yeah.
Plus IEEE paper, that is your project paper, plus project. We'll make it 25%. Presentation. %. Presentation, and that rolls up to 75. Assignments. Assignments will be 10%. That next would be your mid-sem.
Yeah.
So what is left out? 65, 75, 85. This would be 15%. So your exam.
Or we can do mid-sem 10%. You can give this IEEE paper plus project 30% also. You can do it also if you want.
No, the way I have kept it, just want to keep that is final and mid-sem will be 55%. So exam they will write for 55%. Non-exam will be 45%. Okay. So thing is, this IEEE paper for students will not be that difficult, but it will not be very easy also, because you will design a specification we will come across and take it up. So this is going to be the final work. Great. Now, any other questions from the students? I'm keeping it like an industry-oriented level so that you learn more as close to how the industry expects you to learn with that fundamentals rather than being bookish or theory. That is why it is nearly going 45-55. Please speak up. It will be an interactive course. I would prefer to it interaction rather than one way. One way will get very, very boring. Okay, looks like everybody is silent or okay, let me give an ask. So if you all accept with this, go to the chat window and type yes. So until I see about 20 yeses, we will understand that how much of them are okay with it. So we will do a quick survey. How many yes, how many no? I will keep marking as and when I see. Okay, I see one yes. Okay, continue. Second, okay. Third, okay. Only 3. Fourth, 5, very good. I've got 7 till now. So that is typically say I have now 20 people in class. So only 33 people, 33% have voted till now. Okay, we are coming. We've got 9 people, so close to half the class agrees. So does this mean the other half doesn't agree? Okay, let me call out the names who have responded so that others who have not responded, I will get to know. Thanks to Arvind, Vani Harshita, Chaitanya, Venkata Satyasai, Lasya Priya, Farhanaz, Mahesh, Hemashri, Hema Harshita, Geetika. So these are the 9 people who have agreed. So all the others do not like this method. Ten people, 50% we have hit. Okay, looks like 50% is the majority, and the other who don't speak up, I will make a note that these are the people I will keep tracking, because people who don't speak up are very dear to me. I will use them for many other question and answer sessions. So new entries from after hearing, we had Sai Chandana coming up and saying, okay, good. So we have hit the 50% mark. So 50% agree. Greater than 50% agree. So we will continue with the same method. Right. So this is, let us sign today's date. So I want to give the next 10 minutes of this first 1 hour session to students to ask questions. So you need to ask questions so that we understand what are your expectations. Since this is an elective course in the 7th sem, what are your expectations from this course after what you have heard, what I just said? How are we going to divide groups? Project groups, you decide. That flexibility I'll give you. You decide. So send me an email, or we will ask Manoj sir to send out an Excel sheet, which is project group, name of the people, then it will be a table.
I request all the students, please speak up. This is the course. It will be completely different from the other classroom teaching. It's interactive sessions. So kindly speak whatever your doubts, whatever concern, you can speak to him. You can ask him. He is here to help you. I request all the students, please ask your doubts, what your concerns. He will help you definitely.
So please give this in this template: group number, what are group members, and what is a project title. There is only one condition. Each group, each project has to be taken up by at least 3 people, 3 groups minimum. You cannot say all of them we will do one kind of a project. That is one condition. So ideally in 20 people, if I see 10 projects totally, okay, let me change. At least 2 groups per project. 2 groups per project title. And from each group or each project title, one paper we will try and build. So I will again teach about how to write a paper later in the course. We can have a webinar or something for all the people, or I will redirect you to one of my own video lectures. Right? Now this is one part. Now another part for the people who don't speak up. I have a lot of YouTube videos where this CMOS analog IC design is already present. So if you are more enthusiastic, please go look it up. I have sent the link yesterday. So next question would be, somebody asked me, who has asked this? Venkatasai, weekly reports. I don't believe in weekly reports. Okay. The reason is I believe in giving you the power. What does that mean? You will have the responsibility. You are responsible people. I will not ask you reports. My expectation be you will give a completed report. Right? You will draw the schematic. No screenshot. Right? Then you will take good graph, good quality, readable simulation result outputs. Right? for each value that you present in the report, there has to be a simulation result. What are the simulations that you will typically do in the tool? First will be finding out the DC operating point. Second, you will do a DC simulation. Third, you will do AC simulation. Fourth, you will do transient simulation. These are the compulsory simulations that you will have to do. AC, we will get to know what is the static behavior. AC, you will get to know what is the noise plus high frequency behavior. And the transient, you will see the operational or functional behavior. So these are the 4 expectations. So Venkat, like I just mentioned, right, you have to decide your project by September 15th. By September 15th, that is 12 days from now, you should be able to give your project topic. Find out what is the topic that you want to do and use that. So you will be able to add that and take care. Right? So what else? Slides will be shared. Yes, I will find a way to keep it into the Google Drive and I will share the slides with you all.
You can share the slides, everything in the Google Classroom.
Google Class. Okay, that will be good.
The same classroom.
See Google Classroom. Okay, we will use for sharing the slides. Right. I will possibly try and construct a website for this class. Okay, where I will try and host all the material. And all the assignments, if needed, will also be communicated through there.
Or you can post this assignment also the Google Classroom also.
Yeah, assignment will be through Google Classroom itself. Right, so we will do this. And the time taken for each assignment will be given there. Typically, it is between 1 week. Within 1 week, you have to submit the assignment digitally. The assignments I expect is all going to be digital. I do not need a physical copy. Right? I do not need a sheet of paper on which you will write. I need you to do it. Typically, if possible, like how I am writing, use a digital pen and write it in your handwriting and share it. Typed is also okay, but I prefer a digital copy being sent. So that was a question from Lasya Priya. Okay. Good questions. I would rather you speak up rather than type, but either ways, it's good. Because this is an interactive course. If it is not interactive, it might get boring in some time. So let me see who are all the participants who are there. Now, what will happen if I turn on the video of all the people? Let me see. Okay, any more questions? Thank you, Priya. Anything else? I am generally a faculty who does not force people to turn off their cameras. But if there is no interaction, I will kind of ask each one of you individually to turn on their camera. For example, let me do it here. Randomly, let me pick 5 people. Arvind, you start your video. Yes, Arvind. Now speak up, please.
Hi, sir. Good morning.
Good morning.
Yes.
Yes, Arvind. Now speak up. What is your expectation of this course? You are muted, so kindly unmute yourself.
So, as you explained earlier, there will be so much to learn from, like in the industrial perspective. Like until now, we learned everything from the academic perspective. So, I was excited for this course.
Glad to know. Now I know who is Arvind. I will try and recognize next time your voice and your face. So next person I would like is Farah Naz. Stay, video people, please stay on the video itself. Okay.
Morning, sir.
Good morning, Farah. Tell me, what is your expectation from this course?
Yes, sir. I will learn a lot, and it is somehow related to VLSI as well, so which I'm interested into. So a great class, and the assignments projects were also helping for the industrial things as well.
Right. Good. We will see. Next, I'm calling upon Venkata Satyasai.
Hello, sir.
Hello. So, what is your expectation, Venkat? Venkat came and went away. Yes. What is your
As
expectation?
it is my first class, I'm excited. I think I would learn much more from industrial perspective, and looking forward to it, sir.
Great. Okay. Let me call upon.
Sir, had a doubt, sir.
Yes. Good. Doubts. Good.
From you have mentioned some topics, no, sir.
Right.
Can we decide any from it?
Out of the four, you need to pick one.
Okay, sir.
Okay.
Group containing more than 2 or 3.
2 people only.
Okay, sir.
No 3, because I know
Thank you,
3 people doesn't work. Only 2 people in a team.
Okay, sir. Okay, sir.
Yeah. Is there anybody who wants to do more than one project?
I don't think so.
You can turn on your video and tell me, because not now, right? Okay. Let me call upon Hemant Vamsi. Hemant Vamsi Rao. Okay. Chaitanya SK. Hello, Chaitanya.
Hello, sir.
Okay, good. Let me see. There was one other person who asked a question for me. I will call up. Lasya Priya. Oh, by the way, did I pronounce her name correctly? I forgot to ask her. Okay, while she comes up, Sai Chandana.
Yes, sir.
Okay, let me register the face. Okay, right. Karthikeya. You can think this is my way of taking attendance, right? I will finally take the video photos of everybody, put it in the lecture note in the last slide. So if your photo is not there, you are absent for that class. Okay, I need to see your photo. In that, I need to see your video. Okay, that I will put it up. For example, after this, I will put it in this last slide. Okay, I have not seen Venkatasai has gone back. Kiran has gone out. Karthikeya. Okay. Vani Harshita.
Good morning.
Good morning. Dhanashri. So once I call out your name, your video needs to be turned on till the end. If you turn off, no attendance. I am not very particular about attendance. I'm particular about interaction. Okay. Navya Teja. It was the first class, so I need to know, at least recognize you by face. Okay, 3 people are not near their machines. They have gone out. Hema Harshita. Nice.
Hi, sir.
Hello. Okay, now, is there anybody who would like to introduce themselves? I have called out half the class. Or do we have our PhD scholar, Prema Teja? Hope you are here, madam.
Yes.
You will be my main support here. So I would request you to please.
Yeah,
share
one more
your-
thing I just want to say that Prema Teja is a PhD scholar.
Mhm.
So she will be helping in this course actually. She is on the TA for this course.
Wonderful. Thank you.
Yes, sir.
Prema Teja, this is another way of helping get your publication count. You will be supporting each one of them.
Okay, sir.
So you will be their mentor.
Okay, sir.
So every paper they write, you will be part of it
Okay, sir.
along with me.
Okay, sir.
So with power comes responsibility also, right?
Okay, sir.
Right. Geetika. Hello.
Asal
Kiran.
thank you for support the TA government.
Kiran. Oh, Kiran
Sir.
is in his. Kiran is driving somewhere. Huh? He's on his way in a car somewhere.
Sir, actually, I was in an emergency, so
I understand. Rohit. Mahesh. Sivakumar. Very nice.
Hello, sir.
Hello. Venkatasai, Hemant, Karthikeya, not there.
Sir,
Rohit?
this is Karthikeya, sir. I'm here. I'm currently driving, sir. And then it's really my bad to join during class hours, something like that. I'm really sorry for that. Next time during our class, I'll make sure I'll show you my face, sir.
Fair point. Agreed.
And then I'm being honest, this class is something that I really like, sir.
I hope to keep it that way if you support me.
Great, sir. I'm sorry, sir.
That's okay. Navya Teja. Hemashri.
Good
Dhanashri.
morning, sir.
Good morning. Dhanashri. Rohit. Okay. So 3 are physically absent. I will stop my recording with this